Hi, everybody. This one will probably be a lot shorter, and hopefully you'll be a lot nicer to me, because I'm actually the enemy. I'm coming from the streaming side. I'm coming from the Kafka world. And so I was, trust me, I was at Cloudera a long time ago doing Hive, so I'm not a complete enemy, but that's really what we're going to talk about today. I'm all about taking the operational side of your business, the stuff that's powering your microservices and your web apps, and getting that really, really cool data across the big wall that everybody puts in the middle of it and into your Iceberg so that you can play with it. I'm going to talk about 3 ways of doing that today. Inch deep, please come and grab me afterwards if you want to talk about that in any more detail. But it's actually a trick. They're not really 3 differing ways. They're just a progression that we go through in learning how to transfer the data properly. Also, I run a company called Streambase, but that doesn't really matter right now. So starting from right from the beginning, for those of you that are purely batch and stick blinkers and have never heard of streaming before, a stream is continuous flow of small iterative data. It progresses in, it's normally processed in tiny little chunks as it's arrived, and in short, it's Iceberg's worst nightmare. It's if you had to think of a use case that was completely the opposite of what Iceberg was designed for, that's streaming. That's basically what you would have created. So where you have Iceberg optimized for all these great column-based storage, for all these large, high volume pull queries, large batch data ingest and long retention, streaming is the opposite. So we're going to get very, very small amounts of data stuck in. People are going to want to see their updates immediately. We're going to get small retention and all that stuff that we don't like. So I guess the first question we really should ask is, it's going to be really, really hard. Why are we even bothering to do this? Okay. Well, the opportunity is just too big. I don't know how long some of you have been in this game, but I've been doing this for about 20 years. And the opportunity about being able to unify these 2 sides of the data world and have a single consistent source of data that runs from whether you want it from a millisecond ago to whether you want it from 2 or 3 years ago is just too attractive a prospect to pass up. And I was talking to some of you before we came in. I don't actually really care about Iceberg, and I don't actually really care about Kafka. The important thing is they are the standards that won. I don't really care who won. So I'm sure some Delta fans here can fight to the death about Iceberg, but what's important is that we did win. So if you're going to any what do they say, 80% of Fortune 500 companies are using Kafka to run their microservices, you're going to encounter it everywhere, and everyone has standardized around the Kafka protocol as a way to do that. Iceberg, it's not quite there yet, but boy, God, is it catching up really, really fast. Can't go anywhere without talking about Iceberg as the standard for data analytics. So as a picture, I love that because it's 2 standards. You implement them both and you can do just about anything you want. But what's missing is this piece in the middle here. Unfortunately, this piece is still as difficult as it ever was to do any of the rest of it. So that's the bit that we want to look at solving today. We're going to evaluate on, I've only got 15 minutes, so we're going to evaluate on some very, very small criteria. There's lots more than this, but these are the big ones. If you start streaming data into Iceberg, what does it do to your metadata? Probably load your snapshots, create lots of small files, create a load of delete files, and basically grind everything to a halt. We don't want to do that. Also, how do you take wildly different goals in partitioning and apply them to the 2 different formats? You guys probably aren't Kafka fans, but the goal of Kafka partitioning was distribution. The idea that we could assign multiple processes and handle high throughput. No pruning was ever thought about and never will be thought about in that case. But the goal of partitioning in Iceberg is primarily pruning for queries. So how do you marry up those kind of concepts? So they're kind of the Iceberg ones. And down at the bottom, we'll start looking at the real-time kind of things that we want to look at. Number 1 is lag. What's the point of having a dashboard that's refreshing every minute if my data's like 20 minutes old? It's just a waste of time. So how long is it going to be after creation of a data point in Kafka before it's available in Iceberg? And finally, the dreaded schemas. This is a hour at least talk on its own. So I'm only going to touch a little bit on how you have a consistent data structure between your operational world and the analytical world. So without further ado, let's jump in. The first one I'm calling Blast. Blast is as simple as anything. I have rows, essentially rows that are going through Kafka, and I have the ability to insert rows into Iceberg. So every new row, let's insert, no problem. This is typically done by a connector. Kafka Connect is possibly the greatest ETL tool that's ever been created. And it's an endless loop. It's just going, fetch me a record from Kafka and insert it into Iceberg. If anyone wants to try this, good luck. It doesn't work. It's an absolute nightmare. But theoretically, that would be a really, really nice, simple way to do it. And it's got some really great pros. That lag thing that we were talking about, we don't really have that. It's going to come straight out of Kafka, go straight into Smiles. I also don't really have to think. I need to write half a JSON and ChatGPT will figure the rest out. And then my ETL pipeline's up and it's working. And it looks like it scales well. I'll come back to that. But it's got some major cons. Every potential record that comes in here is potentially a new snapshot and a new Parquet file, and bad things start happening really, really fast, unless you do a hell of a lot of maintenance that sucks resources and, well, does all the things that catalogs don't like as well. And you've also got multiple writers writing consistently and constantly. So you've got a hell of a lot of contention around commits. And let's not forget, realistically, all of these Parquet files and tiny things that it's writing and snapshots and all this metadata that's going, this is going to be sat on object storage and you're paying for that. Data that file sizes no longer cost anything. It's opening and closing them that costs the money. Correct. So if we're doing lots of little ones, this is going to start getting really, really expensive. And the final one that I'll come back to, but won't go into too much detail on, is we've still got an operational world over here, a wall that we've chucked some data over, and an analytical world over here. We've done nothing to enforce any kind of consistent structure or practices around there. So all of our governance is still very, very separate and very, very painful. So how do we solve that? Well, let's take the easy bit to solve it first. Round two is going to be a buffer. But the problem was we generate some small files, so why don't we make some bigger files? Hey, no problem. So in this world, we keep the same connector, we keep the same writes, but what we do is instead of throwing every single row at it, we start accumulating them a little bit first. We have some intermediate storage that sits here, and we say maybe after a few minutes or after a specific size or anything, we trigger a process and we throw it into Iceberg. This sounds great, right? It's wonderful. We solved all of our problems. And so, but it's essentially the same process. It's a continuous fetch, insert into temporary storage, then a periodic shove into Iceberg. So we gained really quite quickly and easily. The first thing we gained is we don't have to do the constant compaction. We don't have to do all the constant exploration. We've got big chunks of files and we're moving them across, and that's wonderful. It's still relatively simple. I still get to stick with my half a page JSON, and we've cut the costs because we're no longer doing open close all the time on our S3 models. But we've taken on a big con. We've taken on a lag. So from now on, I have the period where I am accumulating files is not available in Iceberg anymore. In a lot of cases, in the Kafka world, that can be 15 minutes, but it can be hours. It can be a significant delay. And if we want to, I'll go back a couple of slides. If we want to get back to my dream picture, here, then we can't do this anymore. Because these a good chunk of these analytical applications are expecting much, much more recent data than we can provide. It's a slippery slope. Please don't fall into it, guys. But what happens is you put this in, you then solve your technical constraint, because it is only a technical constraint before the security buffer. Then somebody needs some new data, and you suddenly get a prong that goes off over here somewhere. And it goes off to some other kind of more recent storage. And then another one grows over here. And then another one goes over here. And we end up back in this point-to-point ETL hell that we have been in pre-Iceberg and that we were trying to solve. what happens if you create another standard on top of the to unify all the 14 standards? You end up with 15 standards. Yeah, it's exactly that. It's exactly that problem. So we're stuck in this balance. As soon as we can either have freshness or we can have storage efficiency. And it doesn't appear like there's any way that we can have both. This is where it gets sexy, by the way. This is a good part of the talk. So why can't we have both? Well, let me tell you, we did have both almost 15 years ago now. Let's borrow from an old fella called Nathan Mars, and we'll go back to the Lander architecture back in the day. This is exactly the problem that the Lander architecture was designed to solve. You had a batch layer that was providing very, very long retention, very static, very still data. It was enriched with a speed layer that was providing your up-to-minute real-time data. Batch applications can be served directly from the batch layer. Real-time applications can be served from the speed layer, and mixed applications can be served from either layer. Sounds great, yeah? But no one groaned when I said Lander architecture. I think I've got too young a crowd in here. Not just one groans when I say Lander architecture. There's a reason you don't see this picture any more time at the moment. And the reason is the real power and the real meat of this architecture comes from here. Mixed applications are the thing that give you the best, and they're basically impossible to develop. A few people tried. Beam, does anybody remember Apache Beam? I was pretty good at it. That was a pretty good take. I liked that one. But what you have is a wildly different set of concepts from the speed layer and batch layer. And you have to take on the client side in your application, you have to take responsibility for unifying those. And that's really, really challenging, too challenging normally for for people to roll out at any kind of scale. So that's where we were. Let's go into what if world. What if it was all Iceberg? Let's just take a trip down that particular rabbit hole. What happens if we had a way of representing our speed layer, our hot set, as Iceberg, and our cold set that was already Iceberg? What does the unification process for your super powerful mixed applications become then? So let's start from speed layer, union, batch layer. No more kind, like maybe I may have oversimplified it a tiny bit there, but it doesn't become much more complicated than that. Suddenly you're developing really, really powerful, both real-time and batch applications against the same standard, against the same data set. To a client, it sees no difference whatsoever. And no one's like, you guys aren't throwing stuff at me enough tonight. Like, no one said, wait, you can't do that, that's impossible. Yeah.
We're waiting for it to show.
It's coming, it's coming. If we were to do it via a buffer or blast, obviously any kind of file transfer leads us back in the balance, leads us back into the hell of we can either have freshness or we can have storage efficiency. But we can borrow a technique from the database world, and we can implement our speed layer or the Iceberg on top of our speed layer as just as a view. Why not just call it a view? So I come from the Kafka world. Let's say the real-time store was Kafka. The first 7 days of my data stays in Kafka and is Kafka. What we need is at query time, a process to transform that data, just the data we need to satisfy the query, into something that's compatible with Iceberg and serve it up. That's exactly what a view does, but with a few more things. And you get a few advantages from doing this. Number one is we've got rid of our lag problem. When at query execution time, and that's an important caveat in the real-time world, but at the point of query execution, we're working with the very, very latest data that was available. And the reason I say that is in real-time world, you start your query and then you're expecting extra data to come in. We're not talking about that. We're talking about more towards the back world of like, I'm running on the latest data set that was available when I ran the query. We've also subtly, I snuck it in and you didn't notice it, we've also subtly unified all the governance. What it's done is it's shifted the responsibility for structuring our data and for the responsibility for doing access control and things like that into the operational world, into the place where the data is created. So because we have a view on top of our Kafka data, it is our Kafka data that is defining the schemas. It's our Kafka data that's defining the access controls. And you also get the golden standard zero copy. Because we have a batch layer that is then augmented by a view over our Kafka data. If you take, it doesn't really matter what format it is, but if you take any given data point, there's only one copy of it in your list. You're not doing the connector style copy over here, copy over here, copy over here, and hope all 5 copies are consistent. We have one set of data, and that's being accessed in whatever form we need it by the as determined by the client. The second of many times you're going to see this picture tonight. There is a full 40-minute talk I can do on this one, but a very quick one on how we do the how. For a catalog, we just need a REST endpoint, especially if it's not got any fancy features and it just points at a metadata file. For the metadata layer, again, this metadata is computed at query time from the metadata available from your real-time system. None of these files exist in real life. They're just served up as is required by the query. And then finally, on the data layer, I'll just tell you how we do it. Stream-based, we just create a S3 compatible API that sits on top of your Kafka data. There are many ways we can then slice and dice the data that's sitting in Kafka. We just take the opinion that it's just a bunch of bytes, and all we need to do is pull them out. And then we can serve it up just as if it was S3. So basically from here down, nothing exists. This is all fake stuff that's just generated at query time in order to satisfy the query. And that allows us to do a lot. That allows us to do a lot of tricks, apply partition pruning, things like that. No problem. We can just define it here and then we can apply it as needed. So those are the building blocks. Let's put it all together. This is a typical single iteration of what I see as a many iteration continuous process that's happening in your organization in order to provide this single data layer that you can use to serve both real-time and batch analytics. So we start with, actually that speed layer should be really small, but it makes the diagram look rubbish. So we start with a very large batch layer, say with a couple of years of data sitting in Iceberg. That's realistic, no worries with that. And we augment it with a view over the real-time data. It's a very small, say 1 day old. As new data is written, it's written only to the speed layer. It's written only to Kafka, and it becomes immediately available. And so this grows and grows and grows. Eventually, it's going to come to a point where it's not practical for it to keep growing. I mean, we have Iceberg for a reason, right? If we could just let these things grow forever, then why would we bother building the longer term stores? At that point, all we need to do is kick off a process that transfers everything that's sat in the speed layer into the batch layer, which can be as simple as just as bringing them together was as simple as doing a union. Transferring them from new to old is as simple as going insert into the batch layer, select star from the speed layer. Okay, not quite that simple, but okay. I'm using my license. And then once we've done that, we're back at the beginning here. And this is just continuing on and on and on. And because we've allowed this to accumulate, our storage efficiency in Iceberg is very nice. And because we have our views on Kafka with the latest data, our lag is really nice. Because we're using our operational system as the source of truth and copying from it into an old system, we have a unified schemas, and I've totally forgotten what the last one was. Partitioning, oh yeah, and we can apply partitioning in any way we want on the speed layer because it's all at query time, and we can evolve it on the batch layer as you normally would in Iceberg. So we've satisfied all our 4 constraints. We've got a single source of truth that we wanted to get across everything. We're able to serve our real-time clients and we're able to serve our batch clients, and we're all happy. Which is exactly what that says. But just to sum up, the reason we want to join Kafka and Iceberg together is because they both won. They both went through various wars. They both finally won that, and they are the standards for batch and real-time data. Putting them together gives you a single source of truth that's both real-time and durable and if you do it via logical views and things like that, you get simple architecture, reduced cost, and richer mixed batch and real-time applications. In other words, we deliver on the original promise of the Lambda architecture. Thanks very much. If you want this in a lot more detail, come find me after there, or feel free to read the Zero Copy blog I write. And if you'd also like this in a lot more detail, come to Big Data London in 2 weeks and I'll be doing it again. That's okay.
Very much. So let's maybe have just one question here from and then one online.
I'm scared.
I love it. I don't think you're the enemy, you're the friend. So, so you really mean it. So, and first of all, a comment on what you call view. I mean, I know what you mean, but conceptually, I mean this more like a federation technique or for foreign data wrapper, something like that. So because view, I mean, I wouldn't want to mix it up with an iceberg view. It's an iceberg table, so existing. But on that, I know what you mean. One place goes from my head, and I'm trying to remember this all the time when we're talking. With this, can I do or should I do even consider doing CDC with that, where it's more involved reconciliation that is needed, obviously, in this view, quote unquote. On the other side, when I was thinking, I realized, well, when I do CDC, I have data addressed in the source. So I may want to federate that rather than the things on the wire, right?
Yeah.
So it's just it's just glad to happen through.
Yeah, it's a very good question. Can you do CDC? You've both nailed the advantage and the disadvantage and the big problem with doing it. So yes, you could do CDC. The whole point of the view calculation being whatever you want means you could accumulate, you could compute what the end state should be at that point. There are so many variables in doing that. It's kind of scary. But as you said, the big problem is the iceberg data is static. So how do you then reconcile that, the eventual view that an application should see, against what you've already written to iceberg and what you may have written to the speed layer? It's possible, definitely. We have some, I can show you some POCs on it. There's a lot of things to think about though when you're doing it. It's we have it working in very sort of limited cases, but yeah. I get the idea though, it's a really, really nice use case for that, but not today, let's just say. There is a piece missing from the diagram. In order to make the views perform, heavy indexing is required. And that's another thing that we do a lot of at Streamers.
Indexing in Kafka?
Yes.
And that, okay.
Indexing in Kafka is the big win.
So let's probably put that for a networking session. We have one more online question.
There are two, but I don't think actually we'll have time to.
Let's take it one maybe.
Okay. The question was, whether have you tried streaming with Flink or serverless functions, and what are the pros and cons?
Sure, yes. So we encounter Flink an awful lot. So Flink is this is not a stream processing solution. So Flink is optimized for doing the kind of processing that I was talking about earlier. So it's optimized for running processing on very small iterations, maybe building some kind of state, but not expecting to launch queries across huge volumes of data with massive amounts of parallelism. So it has some great advantages depending on your use case. If you have that immediate requirement, then by all means go Flink. But if you want to take a wider, longer term view, then an approach like this might be more suitable.
Professor, thank you very much for your presentation again.